Hello, it's Chinelu here. You're welcome to the second part of solving mathematical problems involving indices. If you remember, well, in the previous video, I told you we are going to be looking at more complex questions. So let's start doing so. Look at this question. We have 81 over 16 to the power of minus 3 over 4. How do you go about handling this question? Now, remember, in the law of indices, when you have something like this, let's say A minus m, okay, you cannot go ahead to start solving when you have a negative exponent or power. What you do, you need to change this. So in changing that, what you do, you're going to have 1 over a m, all right? You introduce the division sign, and then the exponent that was negative here becomes positive. Remember, minus is the inverse operation of plus, so that's the way it goes. And multiplication is the inverse operation of division. That's why here we are dividing. So take a look at this. You can see that they look alike. So what you're going to do here, the first thing we are going to do, we are going to rewrite this, okay? And we are going to have 81 over 16 to the power of 3/4. So now we have a positive power. It becomes easy to solve. Then now we've gotten this, we are going to have 1 over, now whenever you have this here, a fractional power or exponent, here's what you're going to do, is you're going to introduce the root sign, and then the denominator is written here. So it determines what root we find. In this case, we are going to find the fourth root of these numbers. So we are going to have 81 over 16. While the numerator is the power, okay, is the exponent of the power. So we write it here, we have 3. When we get to this stage, the next thing we want to do is to find the fourth root of 81 and then 16. Now, the fourth root means we are looking for a number that when we multiply it 4 times, we are going to get 81, and that number is 3. So we are going to have 1 over 3 over, now what about that of 16? What number do we multiply 4 times to get 16? Is 2. So we are going to have 3 over 2 raised to the power of 3. Now we've gotten to this stage, we need to find its cube, okay? So we are going to have, the cube of 3 is 27, okay? That's 3 times 3 times 3 gives us 27, and the cube of 2 is 8. So by the time we've gotten to this stage, remember I told you, whenever you have a whole number dividing a fractional number, or you have a fraction dividing a fraction number, the inverse operation is going to take place. What do I mean? We are going to have 1 divided by 27 over 8, and we are going to have, from there, we are going to have 1 times 8 over 27. So this is inverted. The denominator becomes the numerator, and the numerator becomes the denominator. So now that we have this, we are going to say 1 times 8, we have 8 over 27. So these are answers. We've succeeded in solving this. Let's take a look at the second example. So let's take a look at this example. First of all, let's observe the bases. If you look at the bases, you're going to notice that we have different bases, okay? We have base 8 here, we have 5 here, and we have 10 here. So the first thing we want to do is to break it down so that we can have the same basis, okay? So what we do here, these two, we can break it down, and breaking it down, 8 becomes 2 cubed. Then raised to the power of 1/3 times, then look at 5. We cannot break 5 down, so we simply write 5 to the power of 2/3 over, how about this 10? We can still break it down. If we say 2 times 5, we are going to have 10, okay? So we write raised to the power of 2/3. So now that we've gotten to this stage, when you have 2 cubed to the power of 1/3, here's what you do. We are going to multiply the powers, okay? In multiplying the power, we are going to have 2, then we are going to say 3 times 1 over 3. We are going to have 3 over 3, okay? 3 times 1 is 3, and 1 times 3, you get 3. So 3 over 3 times 5 raised to the power of 2/3 over, now that we have this, what this expression also means that 2 can be raised to the power of 2/3 times 5 to the power of 2/3. We did this so that we can be able to solve them individually. Now let's take a look at the next step. So the next thing we are going to do, if you take a look at the question, you're going to notice we have same basis. We have 2 here, we have 2 here, we have 5 here, we have 5. So now that we've arrived at this, it becomes easy to solve. So what we do to simplify things, we are going to have this denominator move to the numerator. And whenever denominators move to the numerator, they gain negative power. So this place is going to be negative. Here's what I mean. We are going to have 2 to the power of 3 over 3 now times, this moves to the numerator, it becomes 2 to the power of minus 2 over 3. Okay, then the next thing, let's do that of 5 times 5 to the power of 2/3, then times, now this moves to meet this one, this moves to the numerator. Once it moves, it becomes 5 to the power of minus 2/3. So you can see, once the denominator moves to the numerator, the power changes, it becomes a negative power. So now that we've done this, it becomes easy to solve. What we simply do here, we're going to have 3 go here 1, 3 go here 1. So here we have 2 to the power of 1. Now since we have the same basis, okay, we just pick 2 and then let's handle the powers. So we're going to have 1 plus minus 2/3 times, now we have 5, same basis here, so we just pick 5 and then we are going to have raised to the power of 2/3 plus minus 2/3. So now that we've gotten to this stage, we are going to have 2, when we are going to have 1 plus times minus gives us minus 2/3 times 5, then we are going to have 2 over 3 plus times minus gives us minus, so we're going to have minus 2/3 here. Okay, so now we do that. The next thing we do, 1 minus 2 over 3 is going to give us 1 over 3 times 5, write 5 here, and then 2/3 minus 2/3 gives us 0. So this is raised to the power of 0. So we are going to have 2 raised to the power of 1/3 times, remember in the laws of indices, whenever you raise any base to the power of 0, it becomes 1. So 5 raised to the power of 0 is 1. So we're going to have 2 to the power of 1/3 times 1 is going to give us 2 to the power of 1/3. We can choose to leave our answer like this, but we can further simplify it. Remember, whenever you have a fractional exponent, what you simply do, you have the denominator by this side. So we're going to write 3. So in a fractional exponent, the denominator determines what root we are finding. Like in this case, when we write 3 here, that means the cube root of 2. So we're going to write 2 and then raised to the power of 1. Now, if you do that raised to the power of 1, you still have this as your answer. You're going to leave it as the cube root of 2. So that's our answer. Let's take a look at more complex examples. Okay, so let's take a look at this example. In this example, you can see we have indices in parentheses, okay, is in bracket, and then we have it raised to the power of half. So when you're given something like this, what do? And you're equally to find the cube root. Which one do we start with first? Now what you do, you have to solve for what is in the bracket first of all, okay? We have to handle what is in the bracket. In doing that, we are going to have 64r to the power of minus 6. Then we write, and then to the power of half again. When we have this now, what we are going to do is solve for this. And in solving for this, remember I told you, whenever we have a fractional exponent or power, what we do, we have the root sign. It automatically introduces that root sign, and then you have the denominator that determines what root we are finding. In this case, when you write a 2 here, which may not be necessary because we are finding the square root, so we can write 2. If you like, you write it. If you like, you don't write it. It's still fine. So we are finding the square root of 64r to the power of minus 6. Okay, so what's the square root of 64? It is 8. And then what's the square root of r to the power minus 6? We're going to have r minus 3. Why is this so? If you say r minus 3 times r minus 3, you're going to see that you're going to arrive at this. So you're going to have r and then sum up the powers. In summing it up, you're going to have minus 3 plus minus 3. Then you're going to have r minus 3. Minus times plus gives us minus 3. And then you're going to have r, then you have minus 3 minus 3 gives you minus 6. So you can see how we arrived at this answer. Now that we have gotten the square root of this, the next thing we do is to solve for this. We need to find the cube root. So now we need to find the cube root of 8r raised to the power of minus 3. So what do? The cube root, they are asking ourselves, what number do we multiply 3 times to get 8? It's 2. So the cube root of 8 is 2. And then the cube root of r to the power of minus 3 is r minus 1. Because if you say r minus 1 times r minus 1 times r minus 1, you're going to have r. By the time you sum up the powers, you're going to have minus 3. So you can see how we arrived at the cube root here. So this is our answer. When we get this, you can leave your answer like this, or you can further simplify it. For us to do that, we are going to have 2 times, now this r minus 1 becomes 1 over r raised to the power of 1, which is equal to 2 times 1 gives us 2 over r. So we can leave our answer like this, okay? So this is our answer. So let's take a look at this example. How about when we have something like this? How do we go about handling it? We have the square root of this and plus the square root of this plus the square root of this. So what we do, we start from the smallest one, okay? We start from the smallest one, because what this other one means is the entire square root of the 3 numbers we have here. So what we do, let's make things simple. We start from this small one. So the small one means find the square root of 100 raised to the power of 8. Okay, so now that we have this, what's the square root of 100? The square root of 100 is 10. And then what is the square root of r to the power of 8? The square of r to the power of 8 is r to the power of 4. Remember, if you say r to the power of 4 times r to the power of 4, is going to give you r to the power of 8, because you're summing up the powers, okay, or the exponents. You're summing them up and you're going to have r to the power of 8. Now, observe something. Now we've gotten this. We've got 10r to the power of 4. You can see that we have a like term, okay? You can see that these two have the same power. So we can now sum them up, okay? We can now sum them up. So in doing that, we're going to have 71r to the power of 4 plus 10r to the power of 4, because they are like terms, okay? So when we do that, we're going to have the square root of 81r to the power of 4. Now we've gotten this. What's the square root of 81? The square root of 81 is 9, and the square root of r4 is r2. So we have 9r raised to the power of 2. 9r raised to the power of 2. Now take a look at this and this. You can see they are like terms. So what we've succeeded in doing so far, we succeeded in solving from here to here, okay? So that's the value of from here to here. That's what the value is, 9r to the power of 2. So what we simply do, now that we've gotten this, we are going to sum it up with this and then find the square root. So now we'll have 160r to the power of 2 plus 9r to the power of 2. Finding the square root, okay? First of all, let's sum it up. When we sum it up, we are going to have 169r to the power of 2. Good. So let's find the square root now. What's the square root of 169? Is 13. And what's the square root of r squared? It is r. So this is how we solve it, and we've arrived at our answer. So the value of this is 13r. Okay, so let's take one more example. Go about solving something like this. If you look at this, we have different bases. We have this in base 3, this in base 27, and this is in 81. So whenever you're given something like this, the first thing you want to do is to see if you can have them in the same bases, okay? Let's see if we can further break this down and break this down, okay? Since we have 3 here, we can have this in base 3. So in doing that, we are going to have 3 cubed, then a to the power of 3 times 3 square a to the power of half, okay, over. Now we are done with the numerator. How about the denominator? For the denominator, this 18 to the power of half also means what? The square root of 81, okay? It means the square root of 81 times a to the power of 5 over 2. Now we've gotten the next thing we are going to do, by the numerator, let's collect like terms. You can see that we have same bases here. We have 3 here and we have 3 here. And we equally have a here and we have a here. So in collecting them together, we are going to have 3 cubed times 3 square times a cubed times a raised to the power of half. Now that we have this, the next thing we do, we are going to have 3 raised to the power of 3, that's 3 cubed, plus 2. Remember, when we have the same basis, what we simply do is to add up the powers. Then we are going to have times a raised to the power of 3 plus half. We are adding up the powers. So the next thing we are going to do, by the time we add up the powers, we are going to have 3 plus 2 gives us 5 times a, and then 3 plus half gives us 3 and a half, okay? If you have 3 and a half, we can equally write it as well 7 over 2. So we simply write 7 over 2 over, let's look at the denominators. What is the square root of 81? The square root of 81 is 9 times a to the power of 5 over 2. Okay. Now we've gotten to this stage. We have same basis here. We have a and a. Here we have 3 and here we have base 9. Can we further break this down? Yes, we can. So we are going to have 3 raised to the power of 5 times a to the power of 7 over 2 over, this becomes 3 square times a to the power of 5 over 2. Now that we've gotten this, let's collect the like terms. Let's further simplify. So what we do, we are going to have this denominator move to the numerator. And whenever the denominator moves to the numerator, it gains a negative power. So here's what we are going to have. We are going to have 3 to the power of 5 times 3. This becomes minus 2. We're going to have minus 2 times a to the power of 7 over 2 times a. This becomes minus 5 over 2. Minus 5 over 2. Now we've gotten this, since they are in the same basis, let's pick one. We are going to have 3, 5 plus minus 2 times, then we pick one of these here. We have a to the power of 7 over 2 plus minus 5 over 2. So the next thing we do here, we're going to have 3. Let's sum up the bases. When you say 5, then you say plus times minus gives us minus. So we have minus 2 times a. Then here we have 7 over 2 plus times minus gives us minus. We open up the bracket, we have minus 5 over 2. So which is equals to 3 to the power of 3 times a to the power of 2 over 2, which is equals to, now by the time you have this is going to cancel out. 2 go here 1, 2 go here 1. So we are going to have 3 to the power of 3, that's 3 cubed is 27 times a. Okay, because what we have here is a to the power of 1, and a to the power of 1 is a. So the next thing we have is 27 times a. We now have 27a. So this is our answer. You can see it's absolutely easy to handle. Just follow the steps and you're going to get to the answer. So try practice more questions on this and let me know how well you understood it. So we've come to the end of the second part of solving mathematical problems involving indices. Watch out for the third part of this because we are going to be solving much more complex questions. So if you got value from this video, give me a thumbs up. Do you love to see more videos like this? Hit the subscribe button, turn on that notification bell so that you can be notified whenever I upload videos like this. And don't you forget, maths can be easy. I'll see you in the next video. Thanks for watching.